This video will help you to fill out the top flap of section number 1. Top flap of section number 1, which is called Parabola Definition. And let's go ahead and start. As you can see, I've already pre-written some information here for you. The essential question is, what is a parabola? And here is your definition. This is a different definition than you've learned before. We talked about parabolas as the graph created by a quadratic equation. Now we've got a different, equally true definition. A parabola is the set of all points which are the same distance from a given point, called a focus, and a given line called the directrix. So pause the video for a moment, class, get that definition written down, and we'll go ahead and show you what this looks like on a graph. Okay, hopefully you're done with the definition now. Let's go ahead and draw some points on the graph. So if you would just follow along with me, I'm going to go ahead and put a point at 1, 2, 3, 4, 5. So right here at 0, 5, let's put a red point. We're going to call that, for this example, the focus. Remember, it says a parabola is made from a given point called the focus. There's our focus. And a given line called the directrix. Let's go ahead and draw a line as our example of a directrix. And we'll put it right at y equals 1. Let's go ahead and label that, and I'll write it right below here. It's like the word direct, but then it has trix on the end. So directrix, there is our given line. Now parabola is all the points that are the exact same distance from the focus and the directrix. So you can see, class, that, well, one of the points that I know is the exact same distance between these two things is right here. This point is the midpoint between the focus and the directrix. And that happens to be where our vertex is always going to be for our parabola. So whenever you have a focus and directrix, the vertex will always be the exact middle between those two things. And let's put a point right here just to show you that it's between these 2 points. Now I'm going to try to attempt to show you how a parabola gets formed by finding all the points that are the same distance from the focus and directrix. Let's try this. Not sure how well this will work. It's going to be an estimate, but let's try to estimate this. So I'm going to go ahead and draw a point that is somewhere around right here. And if I put a point right there, you can see that probably, let's go ahead and draw a line segment from the directrix to that point. That point right there is about the same distance from the focus and directrix. Let's try another one. If I draw a line that looks somewhere like right here, looks like that's about this distance away from the directrix. So I'm just estimating this. Get that to be straight up and down. Then I'll do one more. Let's do one more line segment away from the focus. You can see if I draw that line segment, looks like that's about this far away from the directrix. Again, we're just taking a guess here. So I want you to see that if you actually mathematically figured out points that are the same distance from the focus and directrix, you'll actually come up with points that are, oops, let's put that back. Come up with points that look like this pattern right here. There's a point, there's our point, there's our point. If you see, class, if we connect these points together, I'll do my best to show a dashed line through them. You can see we're actually beginning to build an actual parabola. And if I did the same thing on the other side of the y-axis, you'd get the exact same points. And those points together, you can see we're actually building what appears to be the shape of a parabola, and it will be the shape of a parabola. So let's write some notes of our observations here. The first thing I told you is the vertex is exactly between the focus and directrix. Let's just give it a math definition. It's the midpoint between those two things. Okay, one more thing we want to take away from this is there's another value you're going to be working with here, and it is normally labeled the letter P. So let's write that right here. We're going to say this letter P, you're going to see later how this value actually helps you find the equation of this parabola. P is the vertical, let's write the word the a little bit better. P is the vertical movement vertical movement from the vertex to the focus. Now I'm going to highlight these words: from the vertex to the focus. And that means, class, if we're looking from the vertex to the focus, if we're moving up, if to go from the vertex to the focus, we are going up. That means P is positive because we're moving up on the y-axis. If to go from the vertex to the focus, let's say the focus was below the vertex. That means if we're going down from the vertex to the focus, that means P is negative because P is moving in a negative direction from the vertex to the focus. Now keep this in mind. As we go along with this, you'll find out why this is very important. Let's go ahead and put little apostrophes here around P so we know this is the value of P. So in this graph, to go from the vertex to the focus, this is a positive movement. So if we look at this graph, I'm going to go ahead and mark this. You see this. This distance here, or this movement from the focus to the vertex, that is actually the value of P. And I can't really read that very well. I've got a moment here. Let's try to make this readable to you. Let's just put here that this is P. Put that in parentheses. There we go. So we've got a focus, a vertex, a focus, a directrix. The vertex is exactly in between the focus and the directrix, and the movement from the vertex to the focus is going to be represented by this variable, this lowercase p, and you'll see as we move on where that comes into play. So different way to think about a parabola. We'll be seeing with our hot dog cookers and some other word problems how this is relevant to lots of things that you see around you that you use every day.